Okay, in this video I'm going to demonstrate and explain how magnetic shielding works. And also I'm going to try to explain a magnet motor concept that I've seen a couple of people post on YouTube. Okay, here I have two very strong neodymium magnets. Here I have a metal file. With it I'll show you how magnetic shielding works. I'm using this metal file for two reasons. One of the reasons is that the file is mostly made of iron. Iron has high permeability, and the stronger the permeability, the more a magnet will be attracted to it. And the second reason I'm using it is because the gauge gets gradually smaller at the end here. I'll show you how this comes into play in just a minute. Okay, now here I made a contraption out of cardboard to hold the two magnets into place. They're in attraction mode here, but I'll need to put them in repulsion mode for this demonstration. And now I'll show you how magnetic shielding works. Okay, now even though they're both in repulsion mode, they're still attracted to the metal and they will come together. And you can see here it's tough to pull them apart. By putting the metal in between them, I've basically canceled the repelling forces. As I push the magnets closer to the top, where there's less metal, the magnetic shielding becomes slightly weaker. And now you have repulsion and attraction happening at the same time. And if you have the right amount of shielding, you will have equal amounts of repulsion and attraction, effectively neutralizing both forces. And what happens at this point, it takes almost no strength to pull them apart or bring them back together. And now, if you use less shielding, you can gradually bring the repelling forces into play. Alright, now think about this for a second. What would happen if you put the same type of metal rod next to a rotor with the magnet on the end of it? Okay, that's easy. The magnet would be attracted to the closest point on the rod. Okay, now what would happen if we had two wheels? Same thing, right? They would both be attracted to the rod. Okay, but at this point, if you have the right amount of shielding, the repelling and attracting forces would be neutralized, like I demonstrated earlier. Let's go back. Wouldn't the speed gained by the attraction forces push them past that neutral area? If so, the repelling forces would bring them around again. Well, that would be nice, that would make it a lot easier. But what if they don't? Let's say they just stay put. Let's add more magnets here. And if that's not enough to push them over, let's add more here. The incoming magnets also want to get as close as they can to the metal. I think this idea would work, but not like that. You would definitely have to use gears in order to line up the magnets properly. I've learned a lot over the past year and a half about magnets and shielding in the quest to build a magnet motor. I think it's absolutely possible, and I hope you've learned something from this video. Thanks for watching.
The idea of harnessing magnets to create a free energy generator has long been a tantalizing concept. Engineers and innovators have explored using magnets not merely as a source of attraction or repulsion, but as a means to set objects in perpetual motion, converting potential energy into a reliable output. This ultimate magnetic generator concept, where the power source is embedded in the force field of magnets, could transform how we think about sustainable energy. The key to understanding this generator lies in the unique properties of permanent magnets. Over time, magnets have been shown to lift or repel objects, offering a stable and enduring force that, if channeled effectively, could create a continuous rotational movement. This rotational force, when applied to a rotor in an unbalanced magnet system, pushes the disk consistently in one direction. By strategically breaking magnetic symmetry, developers can create a continuous imbalance that forces rotation, a concept that underpins much of the recent experimental work in magnetic generators. The science here is nuanced but fascinating. Normally, a symmetrical magnet system would produce only a single movement in response to attraction or repulsion. However, when the symmetry is intentionally disrupted, magnets create a cycle of continuous force, leading to an ongoing rotational motion. Some developers have already tested this principle, showing how such a mechanism can self-accelerate and potentially generate usable energy. Once kinetic energy is achieved in this way, it can be converted to electricity using a standard AC generator. The rotation from the magnetic system replaces traditional kinetic sources like wind or water, meaning it could offer consistent, weather-independent energy. Building this type of generator is surprisingly accessible. Creating the kinetic source is the primary challenge, one that can be solved with high-quality magnets that maintain their integrity over time. While cheaper magnets may require periodic recharging, this process is simple. Running a DC current through coiled wire around the magnet restores it, extending the generator's life. Despite the controversies and debates surrounding free energy, the allure of a self-sustaining generator powered by magnetic fields remains strong. A world with free energy access would redefine our approach to power. The magnetic generator isn't just a scientific curiosity, it could be the next big step in sustainable energy technology, paving the way for energy independence and environmental stewardship on a global scale.